Welcome all, in this video. Let's discuss about multithreading in operating system. Overview. 1. What is multithreading? 2. How does multithreading work? 3. Types of multiple threading, A many-to-one, B one-to-one, C many-to-many. For advantages. In general, multithreading is the ability of a program or an operating system to enable more than one user at a time without requiring multiple copies of the program running on the computer. Multithreading can also handle multiple requests from the same user. Fast central processing unit, CPU, speed and large memory capacities are needed for multithreading. The single processor executes pieces, or threads, of various programs so fast, it appears the computer is handling multiple requests simultaneously. Next, let's move to working of multithreading. The extremely fast processing speeds of today's microprocessors make multithreading possible. Even though the processor executes only one instruction at a time, threads from multiple programs are executed so fast that it appears multiple programs are executing concurrently. Each CPU cycle executes a single thread that links to all other threads in its stream. This synchronization process occurs so quickly that it appears all the streams are executing at the same time. This can be described as a multi-threaded program, as it can execute many threads while processing. Each thread contains information about how it relates to the overall program. While in the asynchronous processing stream, some threads are executed while others wait for their turn. Multithreading requires programmers to pay careful attention to prevent race conditions and deadlock. Next, let's move on to types of multiple threading: many-to-one, one-to-one, many-to-many, many-to-one. The many-to-one model maps many user levels thread to one kernel thread. This type of relationships facilitates an effective context switching environment easily implemented even of simple kernel with no thread support. One-to-one. The one-to-one model maps a single user level thread to single kernel level thread. This type of relationship facilitates the running of multiple threads in parallel. Many-to-many. In this type of model, there are several user level threads and several kernel level threads. The many-to-many model is compromised between the other two models. If any thread make a blocking system call, the kernel can schedule another thread of execution. Finally, let's discuss about the advantages of multithreading. Economical. They share the same processor resources. It takes lesser time to create threads. Resource sharing. It allows the threads to share resources like data, memory, etc. Responsiveness. It increases the responsiveness to the user as it allows the program to continue running even if part of it is performing a lengthy operation. Scalability. It increases parallelism on multiple CPU machine. It enhances the performance of multiple processor machines.